Good afternoon. Welcome to my second lecture on Fourier series and Fourier transform. In the previous lecture, we have discussed the basic concepts of Fourier series, and there I have said that a periodic signal xt can be decomposed in terms of sinusoidal signals like xt equals to a DC component A naught and the AC components in terms of sinusoidals with the coefficient an cos n omega naught t plus bn sin n omega naught t, right? And n here all integers starting from 1 to infinity, where omega naught is the fundamental frequency, angular frequency. It is 2 pi upon t naught, that is unit is radian per second. And then we have shown that how to compute an, bn if xt is given and also a0, right? So those values we can compute. So we'll give you one example later. Then again we have discussed that we can also express this xt in terms of exponential signals, as this cos n omega naught and sin n omega naught we can also express in exponential form. Like, so we'll go for here. So this is same a naught. So if we rewrite this cos n omega naught as e to the power j n omega naught t plus e to the power minus j n omega naught t upon 2, because cos theta equals to e to the power j theta plus e to the power minus j theta upon 2 by Euler theorem. Similarly, the second term bn times e to the power j n omega naught t, this is minus sign e to the power minus j n omega naught t upon 2j. Don't forget to add this j. So this is your second term. Now this is from 1 to infinity. Now we can rewrite. So as both cosine and sine, they are in terms of e to the power either j n omega naught t or e to the power minus j n omega naught t. So we can express this thing as Cn e to the power j n omega naught t, where n here can start from minus infinity to infinity, all integers, right? Now here you see we can relate between this Cn and An or Bn, all those things. So you see when n equal to 0, that is DC term here. So C0 is same as A0, and Cn rest one we can, so e to the power j n omega naught t, it will be there. This term is here as well as here. So these two we have to combine. So it will be an upon 2 from this first one, and second one, this coefficient Vn upon 2j. So if we rewrite this thing in this way, half, this is an, so we can multiply j both numerator and denominator. It will become j square is minus 1. So it is nothing but minus j bn. It's okay. Similarly, c of minus n, when n is negative, that I will write as c minus n. Okay. So that this second term, this one. So if we consider these terms and these terms, okay. So this is equals to again. So it will be an upon 2, and this time it is minus bn upon 2j. So it is half n plus jbn. You multiply both numerator and denominator by j. So j square will become minus 1, minus minus plus. So it is becoming plus. So this is the relation between Cn and An and Bn, all those. Okay. Now, if we consider real signals, if I consider real periodic signals, for this, obviously we will get A0, An and Bn, all those should be real, because Xn is real, sorry, Xt is real, and it is written as A0 plus An cos n omega naught t plus Bn sin n omega naught t. Okay, n equals to 1 to infinity. Now here this cosine and sine all are real, and left hand side is also real, so this coefficient should be real. Okay, that is the argument. So a0 an means a1 a2 a3, all those things, b1 b2 b3, all coefficients are real. And if they are real, so now Cn, you see Cn is given as, or written as simply half An minus jbn, and C minus n written as half An plus jbn. Now if you look at these two, and if An and Bn are real, then obviously these two are complex conjugate to each other. Okay, so this implies that Cn, if I take a conjugate, star is a conjugate of this one, then we will get next one, means negative one, C of minus n. And opposite also true. So if you take C minus n, its conjugate, obviously I should get Cn. Okay, so what is the meaning of this? That the magnitude, if they are conjugate, then Cn, its magnitude is same as C of minus n. Okay, and the angle Cn should be negative of C of minus n. So these two will get for real. So this, you see, this is the magnitude, this is the magnitude and this is the angle or phase. Okay, so magnitude is even and phase is odd symmetry. Okay, so this is true for real periodic signals. Now let us take one example first, then we will discuss other properties. Take one example, one common example, one periodic signal. It is called square wave. Okay, if I consider this square wave, this is time t. Now square wave I will draw in green. Right, and this side as well. This is a square wave, and this point is t naught. This is your 0 starting point. This is your 2 t naught. Okay, and height we'll consider it's 1. It is -1. And for this periodic signal, we wish to compute the Fourier coefficients. So we can start with the trigonometric form. There we can find A0, AN and BN. Otherwise we can find Cn first, then we can get back those things. Okay, so let us try the second approach. Can I find Cn? So you know that Cn is 1 upon T naught integration x of t e to the power minus j n omega naught t dt. It is for one time period. Now here, suppose I will consider one range from here to here. Sorry. So this here, it is t naught by 2 negative side, and this one is t naught by 2 right side. Okay, so the range I'll consider minus t naught by 2 to plus t naught by 2. Okay, now we can simply break these two part. One is 1 upon t naught is fine, and this is minus t naught upon 2 to 0. This is 1, and next one is again 1 upon t naught is okay. It is 0 to t naught by 2. So for this range, minus t naught by 2 to 0, its value is -1. So that will put directly here, -1, and then e to the power minus j n omega naught t dt. And for this one, 0 to t naught by 2, its value is 1. So this is your xt. Okay. So this is your +1 e to the power minus j n omega naught t dt. Now you can integrate these two, and that is very simple. So first one, this minus sign I will take outside. So minus 1 upon t naught, and this integration is e to the power minus j n omega naught t upon minus j n omega naught, and the range minus t naught by 2 to 0. And for second one, it is 1 upon t0, and again this integration e to the power minus j n omega naught t upon minus j n omega naught. Now limit is 0 to t naught by 2. Now if I combine these two, so 1 upon t naught same, so we can start with this one. So this minus sign, this is minus sign, and so I'll put a bracket here, and e to the power 0 is 1, and this minus 1 is plus. Okay, this one I can take plus sign because this j n omega naught is also I can consider outside. So minus 1 is plus, so this is plus. Here I will put j n omega naught. Okay, so this is 1, and this is your minus sign e to the power minus j n omega naught t naught by 2. This is minus, so minus 1 is plus. I think it is correct. And next one is, now it is minus sign because here it is minus, that I have taken care. Now the first one is e to the power minus j n omega naught t naught by 2, and then it is minus 1. So if you combine these two, then Cn will get 1 upon j n omega naught t naught times, and you see the previous one, anyway this is 1 plus, so this is 2, and then minus e to the power j n omega naught t naught by 2, and then plus e to the power j minus j n omega naught t naught by 2. Is it right? Now we understand that omega naught equals to 2 pi upon t naught. So omega naught t naught, this product is 2 pi. So that you can replace here. So 1 upon j n times 2 pi. So in here it is 2, and this is your minus sign. So minus I can put here, it's okay. So this is e to the power how much? J n, and this is your 2 pi by 2 pi, and this is your e to the power minus j n pi. Is it okay? I think some sign, we are making some mistake here. Probably it was minus sign. Okay, it should be minus sign. Okay, so now what will happen? It is 1 upon j 2 pi n, and this is your 2, and this one it will put j n pi, and you can notice this one. So if I consider one unit circle, then it will be easy to understand. This is your 0, omega theta equal to 0, and any point here it will put j theta, its angle theta. So if it is, this angle is plus pi, and this is, if we move anti-clockwise, it's positive angle. If we move in clockwise, then it is negative angle, then it is minus pi. It's okay. So this pi, it will put j pi is correspond to this point, and that is equal to minus 1. And it will put minus j pi, that is also minus 1. Okay, and then if we move again, come to this point, then it will be your 2 pi, and also it is minus 2 pi if you move this one. Okay, and then this one again it will become plus 3 pi or minus 3 pi, and here it will become plus minus 4 pi. So all even will come here, all odd will be here. So for even you will get this side plus 1, and for odd you will get minus 1. It is true for both. Okay, so I can write it is 2 times minus 1 to the power n, because for odd it is minus 1, and for even it is plus 1. We can write in this form. Okay, so what we will get? So you will see the Cn, then, so if it is even, n is even, then it is 2 minus 2 is 0 for even n, and this is equals to, this is 4, this 2 plus 2 is becoming 4, so 4 upon this j 2 pi n, that means 2 upon j pi n. This is for odd n. So these are the coefficients. Okay, now we can find the corresponding an and bn, all those things. Okay, so now let us write. So this will be useful. So this is for even it is 0, for odd it is 2 upon j pi n. Okay, so xn is summation of Cn times e to the power j n omega naught t, n equals to all. Okay, all means minus infinity to plus infinity. Okay, so this one we can rewrite in this form, that first one is C0 plus, we can combine these two, this C1 e to the power j omega naught t plus C minus 1 e to the power minus j omega naught t. These two, one for n equal to 1, n equal to minus 1. Then again similar to second one, C2 and C minus 2. So in general, Cn e to the power j n omega naught t plus C minus n e to the power minus j n omega naught t, these two can combine like that. Okay. So you see C0 is simply A0, and A0 is average value. As the signal was like this, a square wave like this. So it's positive half and negative half. This positive half and its negative half, it's same. So area within one period it will become 0. So C0 is 0. So simply A0 equal to C0 equals to 0. Right? And now if I combine these two, this Cn, and so we know that what is Cn? Cn equals to 0 for even n, and it is 2 upon j pi n for odd n. Now if we use this one, then what is sum of this? Okay, I want to calculate this part, that Cn e to the power j n omega naught t plus C minus n e to the power minus j n omega naught t, this combination. So this is for this one it is 2 upon j pi n e to the power j n omega naught t, and for C of minus n, n is negative, n is replaced by minus n, so it is minus sign 2 upon j pi n, and it is e to the power minus j n omega naught t. So if we combine these two, so 2 upon pi n here. Now this one e to the power j n omega naught t minus e to the power minus j n omega naught t. This j I can write here, not only j, so e to the power j theta, e to the power minus j theta, minus sign by 2j. If it is 2j, then it is sign. So I will multiply 2 here, and also I will multiply 2 here. Then it will become, simply it is 4 upon pi n, and this is your sine component, sine theta, so sine n omega naught t. So it implies that every pair, this pair, this is one sine omega naught t, this is for sine n omega naught t, and coefficients is 4 upon pi n, and your DC component is 0. So in trigonometric form, that periodic signal expression is 4 upon pi n. So first component is n equal to 1. So 4 upon pi, and it is sine omega naught t. And then even part, even n, for even n it is 0. Then again next odd n is 3. So 4 upon 3 pi, and it is sine 3 omega naught t. Remember, the even part is absent because Cn is 0. And next one is 4 upon 5 pi sine 5 omega naught t, like that it will continue. Okay. So let us try to understand graphically what is happening. So you see, if I draw a little bit bigger, okay. Now if I consider this square wave, square wave I write in red only. It's okay, like that. So this is 1 and this is -1. This is your xt. Now if I consider this one, the first component only the first component, it is 4 upon pi sine omega naught t. So omega t naught is here. This is your t naught. One time period it is 0. This is 2 t naught, like that. So within one time period, this is the first sine omega naught t. The frequency is omega naught. Okay, and what is the amplitude? Amplitude is 4 upon pi, and pi is 3.14. So this is more than 1. Okay, but within this one, so how can I draw this one? So that could be its maximum peak, suppose here, could be like this. It will become 0 here. Right? Like this. So this is your this set as well. So this is your first term, that is for 4 upon pi, this one, 4 upon pi sine omega naught t. And next component, if you draw individually, then we'll try to combine these two together. So 4 upon 3 pi, now 3 is 1/3 of that. So this is the amplitude, it's 1/3 could be here. Okay, so that one I can take one on the line, that would be this height. So I'll try to draw neatly. Okay, so that is the maximum height, 4 upon 3 pi. Now its frequency is triple, means within this t naught you should have 3 cycles. So t naught by 3. So if we divide this way, this is suppose t naught by 3, this is suppose 2 t naught by 3, and this is your t naught. Okay, these 3 cycles. So here I can draw one sine wave. So can I draw one sine wave here? Okay, another one is here. Another one is here. Right? So similarly this one. Okay, so it will continue. Similarly this one. Like that. So this is second term, 4 upon 3 pi sine 3 omega naught t. So if we combine these two together, then what we'll get? So combination of these two, that we are looking for. Now you see here both are positive adding, so here we'll get some quick one. Okay, but in middle you see it is a little bit reduced. So from this one it is a little bit reduced here, some part. Okay, it could be negative as well. So resulting of these two, it could be like this. So I'll draw with different colors. It's okay. One minute. Suppose this one. Okay. Now resulting could be like this. Something here positive and this is negative, and like this. So you see, it is approaching to this one. It will feel better. Okay. So this one is your combination of two terms. First two terms. And if you combine third terms and fourth terms, then you will get better and better. Okay. So what is happening? The square wave, if you include more number of terms, so you may get like this. It will be very, very close to this one. I think you can understand. So this is suppose for number of terms equals to 20. If you go for further, it is again better and better. Okay. So this is the idea. This square wave. Now this one. So what is the spectrum? So if you draw the frequency, okay. So spectrum, I told you that we can draw the frequency content. This is omega. Now it can have, so already we have considered that xn equals to in this form, that it is 4 upon phi sine omega naught t, 4 upon 3 phi sine 3 omega naught t, plus 4 upon 5 pi sine 5 omega naught t, like that. So you'll have those frequencies at omega naught, 2 omega naught, 3 omega naught. So these are possible frequencies because this is the fundamental frequency and rest are harmonics. First, second harmonic, third harmonics, all those things. Okay. But for this one square wave, we don't have any DC component, that is 0. And at fundamental frequency, we have this height 4 upon phi. So we'll consider this one. This is your 4 upon pi. And next one, 2 omega naught is absent. It is 0. And 3 omega naught, there the coefficient is 4 upon 3 pi. Is 1/3 of this one. So it could be here. It's like this. And then 4 omega naught, it is 0. And 5 omega again, it is 1/5 of this one, first one, like this. So you see this magnitude is reducing gradually, but it will contain these frequencies. This is the plot. This is for spectrum. the magnitude spectrum here. As it is only containing sine waves, it is very easy for us to draw. Okay, and we can also plot the Cn part. If I consider Cn instead of this one, so I think Cn was 2 upon j pi n. Okay, so if I consider the imaginary of Cn, no, then this term will be there only, or magnitude, that's better. Magnitude of Cn I want to consider. What is the magnitude? 2 upon pi n. So you see the magnitude here, when n equal to 1, 1 means omega naught, 2 means 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught. And again remember, this is for odd n. And for even n it is 0. Okay, so n equal to 0 it is 0. And n equal to 1 it is 2 upon pi n. This is, and then pi n means n equal to 1, 2 upon pi only. Then n equal to 2 it is 0. Then n equal to 3 it is 2 upon 3 pi. Then this is 0. This is your 2 upon 5 pi, like that. Similarly here, this side, minus omega naught, minus 2 omega naught, minus 3 omega naught, minus 4 omega naught, like that. So here you will get symmetrical. This is same. This is 0. Then this one. Then it is 0. Again you will get next one. Okay. So this is trigonometric form. Trigonometric, where xn is this form, a0 plus summation of an cos n omega naught t plus bn sin n omega naught t. And here this xn is exponential form, the summation cn e to the power j n omega naught t. So this cn, this coefficients here, these coefficients, okay. So to get, if both sine and cosines they are existing, then we have to combine these two together. Then we have to consider resulting magnitude. That will be square root of an square plus bn square. Here it is only sine terms. That's how it is very easy for us. Okay. So, but here there is no negative side, only on positive side. So it is positive spectrum, positive frequency. But this side it is negative frequency, and this side is positive frequency. So exponential form will contain both negative frequency as well as positive frequency. Be careful, this is the difference. Okay, and next video we'll take more example, and some other properties also will be discussed. So this Fourier series will consider the symmetrical properties like odd symmetry, even symmetry, half-wave odd symmetry, and some special techniques like time shifting or derivative. Those things will be discussed. So please follow the next lectures, upcoming lectures. Okay, thank you.